Chapter 4, we're going to be learning about matrices. And so this is going to be the introduction to matrices. We're going to define it and define different parts of what a matrix is. And then throughout the chapter, we'll be learning different operations that we can do with matrices and then some other uses. So matrix, or the plural of matrix, if you have more than one matrix, they are called matrices. The definition is a rectangular array of numbers. Each number in the matrix is called an element or an entry. So down here at the bottom, we have a matrix. We put brackets to show that it's a matrix. And so this one, these are each elements: 3, -1, 0, -6, 4, 5. And it's in a rectangular form. Their uses are for business, science, graphic artists, computer programmers. Whenever we name a matrix, we name it with a capital letter. So this one we could call matrix K. They're in horizontal rows. So when we look horizontally, 3, -1, 0 is a row. -6, 4, 5 is a row. And then if we want to look vertically, we call these columns. So the first column is 3, -6. The second column is -1, 4. And the third column is 0, 5. So rows and columns. Dimensions are given in the form m by n, where m is the number of rows and n is the number of columns. So in this one right here, this would be, we have 2 rows, so it would be a 2 by 3 matrix because we have 2 rows and then 3 columns. So that the dimensions are 2 by 3. A matrix with just one row is called a row matrix. A matrix with one column is called a column matrix. The elements or entries can be denoted by subscripts. The first number represents the row and the second number represents the column. So if we looked at this number 5 right here, we could say this is element. And what we do is we use a lowercase of whatever the matrix is called. So lowercase, and since this 5 is in the second row, third column, we put 2, 3. So obviously we could run into a problem if there were double-digit rows and columns, but we'll deal with that problem when we get there. We won't really do that much. So this would be K, 2, 3. So if we want to talk about this -1 here, this would be K, first row, second column, would be the -1. So there's just an introduction to the different terms. We have rows, columns, elements. State the dimensions of each matrix. All right, so matrix A. Remember, we always go rows by columns. And rows are horizontal, and columns are vertical. All right, so A, we have 2 rows, 1, 2, and 2 columns, so this would be 2 by 2. This one we have 3 rows, 1, 2, 3, and 2 columns, so 3 by 2. This, we just have 1 row, so this would be a row matrix, 1 row by 1, 2, 3, 4 columns, so 1 by 4. And then this one here, we have 3 rows and then just 1 column, so 3 by 1. So those are the dimensions, nice and simple. State the value of each element of the given matrix. So this is, we can denote each element. So C, 1, 2. Well, that means we want the first row, second column. So 1, 2 would be -3. 2, 1. Well, that means we want the second row, first column, which would be the 5. 3, 4, that's third row, fourth column, so -2. And last, we have 2, 3, so second row, third column, which would be a 2. So we can represent data with matrices, and so here we're going to do a column chart to a matrix, but you also could make a matrix into a column chart. So translate the data from the graph into a 2x4 matrix, and they want to call it J, and then state the values of J23 and J14. Well, we want a 2x4. Well, notice under each month we have two things. We have used cars and new cars. So those are going to be our two. So we'll have used cars on top and new cars we can put on the bottom, and then our so those will be our rows, and then our columns can be each month. So let's go ahead and write this matrix J, they told us to call it. And cars sold at JoJo's in January. Let's do our used cars on top. They sold 10. And then the new cars, they sold 15. So remember, this is used cars and new cars. And then February, the used cars was 20. This is at 20. New cars, only 5. March, used cars, looks like it's 19. And new cars, 16. And then for April, used cars was 15 and new cars 20. So 15 and 20. So there is a matrix, a 2x4 matrix. Remember our rows, you don't have to write this, but our rows represented the used cars and the new cars. And then this was January, February, March, April, so the columns are the months. It said state the values of J23, J23, second row, third column, so 16. What does that represent? Well, that's 16 represents the new cars in March, and then J14. First row, fourth column is 15, and that would have represented the used cars in April. Last thing, we can use matrices to represent points on a plane, and in this case vertices. So create a matrix representing the vertices of the figure. Vertices obviously are ordered pairs. So this one's 1, 4. C is 3, 5. You don't necessarily have to write them early. You could just go from the figure here. This is 5, 1. And then point A is -1, -2. And we'll actually start with that one because we can put it in order. So create a matrix. We're going to make a 2x4 where our top values are going to be our x values, and the bottom out values, or the second row, will be the y values. So let's start with point A. That's -1, 2. Point B is 1, 4. Point C is 3, 5. And point D is 5, 1. So remember, these top was x values, and the bottom were the y values. And this was point A, point B, point C, and point D. So it says create a matrix. It didn't say you have to name it. You could have named it, said like M equals or something like that. So there you go. You can take points and put it into a matrix.